Since the beginning of human civilization, we've gazed up at the night sky and wondered about our origins. Where did all of this come from? What set the stars, the planets, and the galaxies into motion? But hidden behind that question lies one that feels even more profound: how will it all end? The universe began with unimaginable power in the Big Bang 13.8 billion years ago, a moment that set time and space themselves in motion. Everything that exists, every atom, every beam of light, traces its lineage back to that instant. Yet, just as every life eventually fades, so too must the cosmos itself. Will it end in fire or in ice? Will everything collapse in on itself or drift apart into infinite emptiness? The answers may already be written into the physics that governs our universe, waiting for us to uncover them. To predict how the universe will end, we first have to understand what it's doing right now. Our universe is expanding, not because galaxies are flying through space, but because space itself is stretching. Edwin Hubble discovered in 1929 that distant galaxies are moving away from us, and the farther they are, the faster they recede. This discovery revolutionized cosmology, revealing that the universe is not static but dynamic, born, evolving, and changing. Later observations from supernovae and the cosmic microwave background revealed an even stranger truth: this expansion is accelerating. Something invisible, which we now call dark energy, is pushing the universe apart faster and faster. It makes up about 68% of the universe, but we still don't know what it is. Is it a property of empty space? A new kind of energy field? Or something we can't yet imagine? Whatever it is, dark energy controls the ultimate fate of everything. The most widely accepted prediction for the universe's fate is the Big Freeze, also known as the heat death. In this scenario, dark energy continues to dominate, driving the expansion forever. Over billions of years, galaxies drift farther apart until they are so distant that their light can never reach one another. New stars stop forming as the interstellar gas that fuels them is used up or scattered. The stars that do exist slowly burn out, leaving behind white dwarfs, neutron stars, and black holes. Over the next 100 trillion years, the last faint red dwarfs will flicker out. The universe will grow darker and colder, as all energy becomes evenly spread: no heat, no light, no life. Eventually, even black holes will vanish through a process called Hawking radiation, evaporating over timescales longer than anything we can truly comprehend. What's left will be a cold, dark ocean of lonely particles, a cosmic graveyard frozen for eternity. But what if dark energy doesn't last forever? What if, in the distant future, its strength begins to fade, allowing gravity to regain control? The expansion of the universe could slow, stop, and then reverse, leading to a catastrophic collapse called the Big Crunch. Galaxies would begin moving closer together, merging into massive clusters of stars. Temperatures would rise as matter compresses, radiation intensifies, and the universe becomes smaller and denser. In its final moments, everything would collapse into a single, blazing singularity, an inferno where all space and time end. Yet, this may not be the final act. Some cosmologists suggest that this singularity could ignite another Big Bang, giving birth to a new universe from the ashes of the old one. If that's true, our cosmos may be just one cycle in an infinite chain of expansion and collapse, a heartbeat of creation and destruction stretching across eternity. Among all the possible endings, the Big Rip is perhaps the most terrifying. It imagines a future where dark energy doesn't stay constant but grows stronger over time. As it accelerates, the repulsive force would eventually overpower all the other fundamental forces. First, galaxies would drift apart. Then, within a few billion years, even the gravitational bonds inside galaxies would fail, tearing them apart. Solar systems would disintegrate as planets are flung away from their stars. In the final minutes, atoms themselves would be pulled apart, the very fabric of matter shredded by the relentless expansion of space. In the last fraction of a second, space itself would stretch infinitely fast, and the universe would end in an instant of chaos. The Big Rip would mean that not even the laws of physics could survive, a total unraveling of reality itself. Dark energy is the key that unlocks every one of these endings, yet it remains the most mysterious thing in existence. It cannot be seen, measured directly, or reproduced in a lab. We only know it's there because of the way galaxies move, faster than gravity alone can explain. Some physicists believe it's a cosmological constant, an intrinsic property of space that stays the same forever. If that's true, the Big Freeze is our destiny. Others think dark energy may evolve, changing its strength as the universe ages, which could lead to a big crunch or big rip. There's even a chance that dark energy could suddenly decay, transforming the structure of reality itself in an event called vacuum decay, a spontaneous reconfiguration of the universe's energy state that could wipe out everything in an instant. Understanding dark energy isn't just about predicting the future, it's about understanding the true nature of existence itself. Even before the grand cosmic finale, the universe will experience a long, slow decline. Stars, the brilliant engines of light and life, will gradually burn out. The most massive ones will die in spectacular supernovae, leaving behind neutron stars and black holes. The smaller ones will fade quietly into white dwarfs. Over trillions of years, galaxies will dim as their last stars die. When star formation stops completely, the cosmos will enter the degenerate era, filled only with stellar remnants and black holes. If protons are unstable, and some theories suggest they are, even the matter in these remnants will eventually decay into radiation. The night sky will grow darker until no visible light remains. The universe that once blazed with 1 trillion suns will become a place of eternal twilight, lit only by the faint whisper of decaying matter. After the death of all stars and matter, only black holes will remain, silent sentinels of gravity scattered across an empty cosmos. These will be the final rulers of existence, and they too will meet their end. According to Stephen Hawking, black holes slowly emit radiation due to quantum effects near their event horizons. Over unimaginable timescales, they lose mass and energy, shrinking bit by bit until they vanish completely. Smaller ones disappear first, while the supermassive black holes at galactic centers may take up to 10^1 years to evaporate. Each death will release one last flash of energy, the final fireworks of creation. When the last black hole disappears, the universe will enter its final age, the dark era, a place with no structure, no light, and no future, where time itself has little meaning. Yet even in that cold void, some scientists believe the story might not be over. In quantum mechanics, empty space is never truly empty, it's filled with tiny fluctuations of energy, constantly appearing and disappearing. Over incomprehensible stretches of time, one of these fluctuations could trigger a new Big Bang, creating an entirely new universe. This idea, called cosmic inflation or eternal inflation, suggests that our universe is just one bubble in a vast, ever-expanding multiverse. New universes could be forming all the time, each with its own laws of physics and unique realities. Perhaps the death of our universe isn't a tragedy, but a transition, the passing of the torch to new realms of existence we can never see. In that sense, the universe never truly ends, it simply transforms. Thinking about the end of the universe can feel overwhelming, even hopeless. Yet it's also deeply beautiful. The cosmos is vast beyond imagination, and we are part of its fleeting moment of light. Everything we see, from the glow of galaxies to the spark in our eyes, is temporary. But that's what makes it precious. We exist in a narrow window between the universe's birth and its death, a rare moment when the stars still shine, when life is possible. To understand that, and still find meaning, is perhaps humanity's greatest strength. So as we contemplate the end of all things, remember this, we are the universe made conscious, able to witness its own story. And maybe that awareness, that fleeting spark of understanding, is the universe's greatest miracle of all. Because even when the stars go dark, curiosity, our need to know, will always shine brightest.